In this video, we're going to develop a model of aggregate demand for business cycles. We're going to assume that GDP is going to be determined by aggregate demand, so we're going to ignore all the supply constraints that might exist. We're going to build it by having 3 blocks, and each of these blocks we're going to represent graphically and then solve for the equilibrium of the model. Now let's describe each of these blocks in detail. The first block is the most fundamental one, because it describes the 4 components of GDP that come from the definition of GDP: private consumption, investment, government consumption, and net exports. Now we have to ask what determines each of these components of GDP. Now when we think about private consumption, C is going to be determined by income, the income of the consumers, of course adjusted for taxes, so we're going to think in disposable income, income after taxes, the interest rate, which is going to be the cost of borrowing or the return to saving, and then any other factor that might increase or change consumption, like wealth, expectations of consumers, etc., etc. Now, what the signs in the brackets are here are telling us in which direction these variables affect consumption. So, of course, higher income means more consumption, higher taxes means lower consumption, higher interest rates mean lower consumption, and higher wealth means more consumption as well. Now we'll do the same for the other variables. For example, investment will depend on the interest rate, the cost of capital. Of course, higher interest rates will affect negatively investment. And then it will depend on any variable that can indicate the expectations of businesses about the profitability of future investment or current investment. And that's going to have a positive sign because higher expectations of profitability will mean higher investment. Now, government spending will treat it differently. We'll treat it as a variable decided by governments, so we don't have to think about the determinants of that variable. Finally, net exports will be determined by exchange rates. Exchange rates will help us understand the cost of our goods relative to costs in other countries. So higher exchange rate means our goods are going to be more expensive relative to the rest of the world, and it also means that our exports will go down and our imports will go up, which means we're going to put a minus sign here in front of the real exchange rate. Now, the other 2 variables are the income of our country, the GDP of our country, and the GDP of other countries. And those variables enter with the following signs. If our income increases, we expect more imports. More imports means our net exports will be lower, and that's why we have a negative sign. If the income of other countries increases, we expect more exports. They're going to buy more from us, and that's why we see a positive sign there. We're going to summarize all of this into one expression that has our 4 components, C, I, G, net exports, and within brackets we're going to include any variable that can potentially affect these 4 components. Let's move to block number 2. Block number 2 is going to be about the money market and the way the central bank is going to influence that market. We have 2 sides of the market: the money supply, which is controlled by the central bank, the money demand, which is going to come from the private sector, and we're going to put the 2 together. The left-hand side of this equation is going to be the money supply. The right-hand side is going to be the money demand. The money supply is going to be straightforward. Liquidity is determined by the central bank. The only small technical issue we need to deal with, we need to measure money in real terms. And that's why we rescale money by the price level. You see M over P, money divided by the price level. The right-hand side is the demand for money. And we can think about it as depending on 2 variables. GDP, which captures transactions. Remember, liquidity is about the asset that is needed to do transactions. So the higher the amount of GDP, the higher the number of transactions, the more money demand there will be. And then the interest rate, in particular the nominal interest rate, we'll use a letter I for that. And here we have a negative relationship because the nominal interest rate is the opportunity cost of holding money. The higher that number, the less likely it is that I want to hold money. So here's block number 2. It's a money market. It's like any other market, supply and demand. And we can get some intuition about how the central bank influences this market by represented graphically this block, the money market. Now let's do it quickly. We have here the money supply, which is going to be vertical because we have money on the horizontal axis as the quantity in this market. Now the price is going to be the interest rate, the nominal interest rate, that's on our vertical axis. And there's going to be a money demand that depends negatively on that price, therefore is downward sloping. Now, how central banks affect this market? How do interest rates or money move when central banks act? We can look at it from two sides, but you will see in a second we're going to get the same intuition regardless of which side we're looking at it from. Let's start with a notion that central banks can change liquidity, so they affect quantities. What if the central bank increases the supply of money? What do we learn from this market? Well, we learn that the vertical line is going to shift to the right, and in equilibrium, we're going to see a lower interest rate. So there's going to be an inverse relationship between interest rates and the quantity of money. We can get the same intuition if we think about central banks not at setting the money supply, but at setting the interest rate. So what if central banks, they define their policy as a level of interest rate as opposed to a level of liquidity? Now, you will see here now that as the central bank decides to lower the interest rate, in equilibrium, we're going to end up with more liquidity because as interest rates go down, commercial banks are more likely to borrow from the central bank, and that is going to lead to higher liquidity in the market. Now, we end up with the same inverse relationship between liquidity and interest rates that says we can think conceptually about central banks either as increasing liquidity or lowering interest rates, but fundamentally, we're moving from the same equilibrium to the same new equilibrium. So in the analysis that follows, we'll use any of the two variables to think about central banks. We can either talk about quantities, liquidity, or we can talk about interest rates. That was our block number 2, the money market. Let's move to block number 3. We need to think about capital flows, exchange rates. Now here we're going to take a very simple approach. Exchange rates are determined by demand and supply in the foreign exchange market. And we're going to simplify this market by saying it's driven fundamentally by capital flows of investors that are trying to seek the higher return. So if I see a higher return in a foreign country, in another country, I'm going to move my capital there. And the other way around, if we offer a higher return than the rest of the world, capital will come in. Now, how do we summarize those capital flows? By thinking about an equation that captures the no arbitrage opportunities situation. So we're going to assume that capital flows are large enough that at the end, we always see equality between interest rates, between our country, we call that R, the real interest rate, and the rest of the world, the foreign real interest rate, that we call R with an F on top. Now, what this expression says is if we deviate from this equilibrium, we're going to see capital inflows or outflows. Now, we now have the 3 blocks. We have an aggregate demand block, all the 4 components. We're going to call that block, that equation, the IS curve. We have a money market block. We're going to call that equation the LM curve. And then we have an exchange rate determination, capital flow, arbitrage equation that is going to give us the equality between real interest rates. Now, as we think about representing these 3 equations, we're going to introduce an assumption that is going to help us get rid of the dynamics of a variable that we don't need to look at today because we're only looking at the demand side, not the supply side. Now, that assumption is basically, let's get rid of inflation. Let's not worry about inflation dynamics. Another way of saying is the price level is going to be constant. Prices are not going to change in the slides that follow. Now, how does the model change? How do these 3 equations change if we introduce that assumption? First, the price that you see on the second block, the money market, is going to stay constant. That means we don't need to look at that price anymore. We're going to get rid of it. We'll just see M. Second, any variable that is either real or nominal is going to be identical. The real interest rate, the nominal interest rates are going to be identical. The real exchange rate, the nominal exchange rates are going to be identical. That means that the letter R that we use for our real interest rate is going to be equal to the letter I that we use for our nominal interest rates. So anytime we see those variables, we're simply going to call them the interest rates, and we'll use the letter R to reflect that. And the real exchange rate, which we call E with a letter R on top, we're simply going to be call it E, the exchange rate, because we don't have to make a distinction between nominal and real exchange rates either. If we replace all those letters with the new letters, we have the three blocks, no more prices, no more real versus nominal variables. Now what comes next is, let's solve the model. We're going to do that graphically. So we're going to take our three equations and we're going to represent them graphically. Now we need to choose two variables that we believe are the most interesting ones, the ones that we need to keep track of. Now there's plenty of them here, but we're going to choose GDP and the interest rate. So what will we do is we'll represent these two variables on the two axes. And what we will do is then any other variable that is not one of these two, if it changes, we're going to have a shift in one of these three curves. Now let's do it. The way we're going to do it, we're going to represent each of these curves first graphically, then we'll put them together, and then we'll do a couple of examples. Let's start with the first block, what we call the ice curve. What does this equation look like in this space? Now take an initial point, and let's assume that in this intersection, this equation holds. Let's move one of the two variables, either the interest rate or GDP. Let me move interest rate down in this case. Now, if you stare at the equation, you will see as the interest rate goes down, consumption is likely to increase. Remember, consumption depends negatively on the interest rate. Same for investment. So GDP is likely to increase, which means as we go down, we're going to move to a higher level of GDP. In other words, this curve is downward sloping, and this is the ice curve, the first block of our model. Let's do the same thing for the second block, the second market, which is the money market. Same logic, we start somewhere in this space and assume that at this intersection we have the equilibrium in the money market, supply equal to demand. Let's move one of the variables. I'll move the GDP to the right. In this case, as GDP increases, money demand will increase because there's more need for transactions, more liquidity need for transactions. Given that the money supply is constant, that means the interest rate is going to increase. In other words, as I move to the right, I need to move up. Therefore, the LM curve is going to be upward sloping. And now we have the final curve. This curve is very easy to represent. It's just a horizontal line because there's no GDP in this equation. We just have one number, which is the foreign interest rate. And if we plot it here, we're going to see this horizontal line. But now we need to think carefully about what we learn here. Here, what we learn is something about the dynamics of capital flows and exchange rates. In particular, if I ever find my economy above this horizontal line, it means my interest rate is higher than the interest rate abroad. It means I'm going to see an inflow of capital. An inflow of capital is likely to appreciate my currency because the foreigners want to buy my currency to invest in my country. If I ever find myself below this horizontal line, it means I have an interest rate of return which is lower than other countries. I'm going to see an outflow of capital. As capital moves out of my country, my currency will depreciate. So what we have with this line is something which is different from the other two. Here we have the space divided into two halves, the top and the bottom, and these two halves tell us something about the changes in the exchange rate. Let's put the three blocks together to see what's going to happen. We have three lines. If they intersect on the same interest rate, same level of GDP, that's what we're going to call an equilibrium. Now, what is it that we're going to do now? We're going to think about changes in the environment. Something is going to happen, an exogenous event, a change in policy. That is going to shift one of the three curves. Once we see that, we're going to ask ourselves, what happens to capital flows? What happens to appreciation or depreciation of our currency? If there is such change in the exchange rate, we're going to have to think about changes in net exports. As net exports change, the IS curve is going to shift because that's where net exports are, and we're going to continue doing this until we find a new equilibrium. By new equilibrium, we mean an intersection of the three blocks. There's just one small detail that we need to take care of before we look at that, which is we're talking about capital flows moving exchange rates. But some countries have fixed exchange rates, so exchange rates cannot move. Now, how are we going to deal with it? We're going to always separate between countries with flexible and fixed exchange rates. In a country with flexible exchange rates, our capital flows will make the currency fluctuate. In a country that has fixed exchange rates, the central bank will be required to intervene to keep the exchange rate constant. So we'll see the same pressure on the currency, but the outcome will be very different. The exchange rate will not move. Now we're done with the three blocks. We have the graphical representation. This is what we're going to do now. We're going to shift one of the three curves. Now, when does the first curve, the IS curve, shift? When anything happens that you could call an increase for demand. So the curve will shift to the right if there's an increase of demand. The curve will shift to the left if demand goes down. Now, how can demand go up? Well, we can think about potential changes in the economy that will make demand go up, government spending going up, taxes going down, investment and consumer confidence going up, and many other factors, wealth going up, etc., etc. The LM will shift to the right every time liquidity in the economy increases. Now, that can happen because the central bank increases the money supply. That could happen if we go back to a world where prices move. If prices go down, because then money measured in real terms will also go up. Or there could be a change in demand that is sort of the mirror image of an increase in liquidity, in particular, a decrease in money demand. So any change in financial innovation that makes people hold less money will also shift the LM curve to the right. The third block is very easy. Remember a horizontal line. When will that horizontal line change? If the foreign interest rate changes. If it increases, the line will shift up. If it decreases, the line will shift down. Now let's do two examples here. Let's start with an example of a change in monetary policy in a country that has flexible exchange rates. So we're going to think about a country where the central bank decides to increase liquidity. What happens in this graph? Now we know the LM will have to shift to the right, because that's one of the conditions under which the LM shifts. That also means we move slowly down here. We move to a world where our interest rate is below the interest rate in other countries. At that level, we expect an outflow of capital. An outflow of capital is likely to lead to a depreciation of our currency. That will increase net exports because we are more competitive than before. Net exports will shift the IS curve to the right. How far? Well, until we reach a new equilibrium. That new equilibrium is where the three lines intersect again. So what do we learn? We learn that expansionary monetary policy increases GDP through effects on interest rates initially and later on the exchange rate and net exports. And we end up at a place where our interest rate goes back to the foreign interest rate level because it has to. That has to be the new equilibrium, but our GDP is higher than it used to be. Finally, let's do a second case. Now we have fiscal policy. We're going to do expansionary fiscal policy in a world where exchange rates are fixed. So here the central bank is committed to keep the exchange rate constant. First step, let's think about the government increasing government spending. That's an expansion in fiscal policy. You could think about a cut in taxes. It will be identical to what we're doing here. We know that changes in government spending will shift the IS to the right. So the economy has a tendency to move all the way up here where the LM and the IS intersect. More GDP means more demand for liquidity. We need to do more transactions. Interest rates start increasing. As interest rates go up, we expect to see a capital inflow. But a capital inflow is going to put upward pressure on our currency to appreciate. Foreigners are coming to take advantage of our higher returns. But here we have fixed exchange rates, remember. The central bank cannot let this happen. What does the central bank do? They sit on the other side of the market, avoiding the appreciation of the currency. How do you do that? All this demand for our local currency is going to be met by the central bank, which is going to increase the money supply to ensure that the price of our currency doesn't go up. But an increase in the money supply is going to shift the lamp to the right. We end up in the new equilibrium where all the three lines intersect. What did we learn? We learned that in this world, expansionary fiscal policy increases GDP, and that partially happens because liquidity has to increase in order to avoid the appreciation of the currency. So the central bank has to automatically react to this particular policy of the government in order to ensure that the exchange rate is fixed. So second example, fiscal policy, fixed exchange rates, we also get this expansionary effect, but the channels and the way the central bank reacts is of course very different than when we had flexible exchange rates.